Rahim. Assalamu alaikum dear students. This is our next problem. Problem as usual having been chosen from the book Modern Physics by Kenneth S. Crane. As usual we first come to its statement. Okay. Statement of the problem is an electron is in the n equal to 5 state of hydrogen. An electron is in the n equal to 5 state of hydrogen. To what states can the electron make transitions? And what are the energies of the emitted radiations? Okay. We have to discuss transitions from one energy level to another, from one state to other. And in addition we have to also find energies of these radiations having been emitted. Okay. An electron is in the n equal to 5 state of hydrogen. To what states can the electron make transitions, and what are the energies of the emitted radiations? Okay. Number 1 transitions and number 2 energies. Okay, we have to find two things. State is n equal to 5. Okay, when n equal to 5 state is under consideration, then obviously lower states, that is n equal to 4, n equal to 3, n equal to 2, n equal to 1, automatically become under consideration. Okay. Anyhow, when we will deal with its solution, things will become clear. Okay. Because dear students, in every problem many things are hidden in helping tools. When we apply those helping tools, then our concept become clear. Okay. So we now move to helping tools. Okay. How many tools? I think there is only one helping tool, but its various versions have been used. Okay. 1, 2, 3, 4. Okay, 4 versions. Yes. Helping tool is only one, but I have chosen snapshots from 4 different books. Okay. Our first version has been chosen from the book which we are following, that is Modern Physics by Kenneth S. Crane. Okay. About remaining snapshots I am not clear for the time being. Okay. Anyhow, version 1 of our helping tool says that energies of Bohr orbits in hydrogen En is equal to En is equal to minus me raised to the power 4 divided by 32 pi square epsilon naught square h cut square or h bar square or h reduced square. Okay, into 1 over n square, and this alternatively becomes equal to minus 13.60 electron volt over n square, where n is equal to 1, 2, 3. Okay, dear students, this version we will apply. In this version, okay, m is mass, is elementary charge, pi is 22 by 7, epsilon naught, its value is given in table, various tables. H cut square, H cut is equal to H over 2 by, and n is the number of state, n equal to 1 to 3, and this is alternatively being equal to this minus 13.60 electron volt over n square, where n is equal to 1 to 3, and so on. So dear students, our nature of problem is such that we have nothing to do with this intermediate portion or prior portion of expression. Okay, that is, for the time being, we have nothing to do with me4, epsilon naught square, h cut square. Okay, we will use just this second expression. Okay, that is, we will use this expression En is equal to minus 13.60 electron volt over n square, where n is equal to 1 2 3 4 5 and n equal to 5 is our given state in the problem. Okay, so if we consider the whole helping tool, that is whole expression, into consideration, then it becomes a little difficult or hard. Okay, no doubt various parameters are involved in this expression, but as I have said, that our problem is of the nature that for the time being we are not concerned with this difficult portion of expression. Okay, we can exclude or eliminate or disregard this intermediate portion, and its equivalent value, that is minus 13.60 electron volt over n square, is quite simple, easy, and there is no confusion. We have not to work more on this. Okay, in our subsequent problems, definitely we will have to deal with this quantity me4 over 32 pi square, epsilon naught square, h cut square, n square. Okay, definitely in that portion our calculation will become lengthy or laborious, etc. Okay, but for the time being we have been facilitated by this equivalent value, so our expression is quite simple, that is En is equal to minus 13.60 electron volt over n square. Okay, so we will follow this route and our problem will be solved quite easily. Now we move to next version of this helping tool. Next version, what does next version say? Next version is quite simple and is just a repetition of first version, except the difference that intermediate complicated portion has been eliminated from this expression. Okay, so if we compare first version and second version, we come to conclude that second version is much more easier than first version, but at the same time first version is also quite same as version number 2, because if we compare these two versions, we conclude that this intermediate portion, which is enough complicated, is not of very much importance for us to the extent of this problem, and in the absence of this intermediate complicated portion, our expression becomes quite simple, easy, and straightforward. Okay, now third version. Now we come to third version and we compare what is the difference between third version and first two version. Okay, third version says that En is equal to minus me raised to the power 4 divided by 8 epsilon naught square h square n square. What is the difference? Yes, quite. Dear students, actually h cut is equal to h over 2 pi. Okay, the difference between first version and third version is that in first version h cut has been used, and we know that h cut or h bar or h reduced is Planck's constant h divided by 2 pi, and we know that pi is equal to 22 by 7, which is usually taken as equal to 3.14, but it is a very special number. The speciality of this number is that its decimal representation is non-terminating and non-repeating. Okay, decimal representation of pi, which is equal to 22 by 7, is non-terminating and non-repeating. After decimal digits change, they do not repeat their pattern, and this pattern does not come to any end. Okay, this is a very surprising situation, but what can we say? It is a fact. Okay, so dear students, when we compare version 1 of our tool with version 3rd of this helping tool, we conclude that the difference between first version and third version is that in first version h cut or h bar or h reduced has been used, which is equal to h divided by 2 pi. H is Planck's constant. Okay, so when we use here in place of h cut, we use h over 2 pi, then definitely to square of 2 pi, that is 4 pi square. So due to this difference, this expression takes a similar form. Okay, so it has become quite clear that the only difference between first and third version is that here Planck's constant has not been used, rather Planck's constant h has been used in terms of h cut or h bar or h reduced, which is equal to h over 2 pi. Okay, due to this reason there is a some apparent difference in the form of intermediate portion of version 1 and third version of our helping tool. Okay, remaining portion is quite similar. Now we come to fourth version. Fourth version says that En is equal to minus 1 over n square, h cut square over 2 ma naught square is equal to E1 over n square is equal to minus 13.6 electron volt over n square hydrogen energy level. Okay, here once again, dear students, only intermediate portion is slightly different. Okay, so we assume that we are not considering this intermediate portion. Okay, we are just considering En equal to minus 13.6 electron volt over n square. When we take this thing in mind, that En is equal to minus 13.6 electron volt over n square, then all these four versions become absolutely same, absolutely equal, 100% equal. Okay, only their equivalent value or equivalent expression, which is shown as intermediate portion of the expression in version number 1, 3 and 4, is slightly different, and for the time being this complicated portion is not of any importance for us, so we leave this controversy. Okay, and now we come to our solution in a formal manner. Okay, solution. We know that energies of Bohr orbits in hydrogen are given by En is equal to minus 13.60 electron volt over n square, where n is equal to 1, 2, 3 and so on. Okay, what we have done, we have used tool number 1, irrespective of whether we are following version 1, version 2, version 3 or version 4. Okay, because in all those versions we have rejected intermediate complicated portion. Okay, when we reject or neglect intermediate complicated portion, then all the four versions become 100% equal, 100% equivalent, 100% same. Okay, so this discussion has become to an end, and we have applied tool number 1 in this beginning part of our solution. Okay, in which intermediate portion has not been taken into consideration, because for the time being that thing is not of our use. Okay, so quite simple, very we can say that perhaps we can say that extremely simple form. Okay, this implies that here what we will do, n equal to 5 is given in this statement, and I have said that when n equal to 5 is our primary state, then definitely lower states, that is n equal to 4, 3, 2, 1, obviously become under consideration. Okay, so here what we will do, one time we will put n equal to 1 and we will get the value of E1, then we will put n equal to 2 and get value of E2, then we will put n equal to 3 and get value of E3, then we will put n equal to 4 and get value of E4, then we will put n equal to 5 and get value of E5. Okay, so when we put n equal to 1, then we assume that there is 1 in the denominator, and when 1 is in the denominator, 1 needs not to be expressed separately. Okay, so the same value becomes its answer, that is 13.60 electron. But when we put n equal to 2, then the result of E1 has to be divided by 4, because square of 2 is 4, and hence N2 E2 becomes 1/4 of E1. Okay, E1 has become equal to minus 13.60, while E2 has become minus 3.4 electron volt, because in E2 n is equal to 2 and 2 square is 4 and 4 is in the denominator, so E2 is fourth part of E1. Similarly, in E3, E3 square of 3 is 9 and 9 is in the denominator, so E3 is ninth part of E1. Okay. So E3 becomes equal to minus 1.51 electron volt. E4 square of 4 is 14 and here 14 is in the denominator, so value of E4 is 16th part of E1 and hence that is to say E4 is equal to minus 0.85 electron volt. Similarly, for E5 square of 5 is 25 and 25 is in the denominator, so value of E5 is 25th part of E1 and hence E5 becomes equal to minus 0.544 electron volt. Okay. So dear students, this portion that is from E1, E2, from E1 to E5 basically is of primary school students level, but because our methodology thinks this difference as inappropriate and we try to elaborate everything in such a way as if viewer or student has a less previous background. Okay, so E1, E2, E3, E4, E5 calculation being of a primary school level, but we have given enough time and found its value quite satisfactorily. Okay, now we come towards transitions. Okay, it will also be quite similar to above mod, because we have to find various transitions. When we find one transition, then remaining transitions can be compared with that single transition which we have calculated for the first time. Okay, now we come towards transitions. Okay, now transition from n equal to 5 to n equal to 4. Okay, we are taking into consideration this transition. For this transition, delta E is equal to E5 minus E4. Okay, and we have both values E5 and E4 in previous part of this problem. We just put these two values and their difference becomes plus, because dear students, E4 value of E4 is already in minus or negative, and we know that negative thing here becomes plus, because it is a basic principle of multiplication that two similar signs when multiply their resultant is positive, while when two different signs multiply their result or resultant is negative. Okay, so E5 minus E4, value of E4 is already in minus, so minus with into minus, both signs are similar, minus minus, therefore their result is positive plus. Okay, here E4 is equal to minus, but here E4 becomes plus. Okay, so our delta E, that is transition, becomes plus 0.306 electron volt, because this second value is greater than this first value, So this plus sign overcomes being a larger value. Okay, now transition from n5 to n3, that is delta E equal to E5 minus E3. Here once again same situation as in previous transition, that value of E3 which is actually minus 1.51 electron volt, here it becomes plus, because I have already said that when two similar signs are multiplied, their result is plus. When two different signs are multiplied, their result is negative. Here, because both signs are similar, that is minus into minus, so their result becomes positive, and this positive value is greater than this negative value, therefore positive sign predominates and delta E becomes equal to 0.966 electron volt. Okay, now we move to next transition. Okay, now transition from n equal to 5 to n equal to 2, that is delta E change in energy. Delta always denotes change. Okay, so delta E is equal to E5 minus E2 is equal to minus this plus this. Okay, once again value of E2 is actually in minus, but here it becomes plus, because minus minus both signs are similar, therefore their result is positive. Okay, and here 3.4 is greater than 0.54, therefore resultant sign is also plus positive. Okay, now last transition from n equal to 5 to n equal to 1, delta E, that is change in energy E, is equal to E5 minus E1 is equal to minus 0.544 electron volt plus 13.6, while we know that E1 is minus 13.62, but as we have said many times in this regard, in this connection, that when two multiplying signs are similar, their result is positive. When two multiplying signs are different, their result is negative. Here, because both signs are similar, that is both are negative, therefore their result is positive, and this value is much greater than this minus value, therefore positive sign prevails, and their difference is 13.065 electron volt, and this is the last transition. So we have also calculated E1, E2, E3, E4, and we have also found these transitions from n equal to 5 to n equal to 4, then n to 5 to n 3, from n equal to 5 to n equal to 2, and in the last from n equal to 5 to n equal to 1, and hence we once again, dear students, we once again just point out our resultant values which should be considered as our solution. Okay, so our solution is minus 13.60 electron volt, minus 3.4 electron volt, minus 1.51 electron volt, minus 0.85 electron volt, minus 0.544 electron volt. And in case of transitions, the first result of first transition is 0.306 electron volt. Result of second transition is 0.966 electron volt. Result of third transition is 2.856 electron volt, and result of last transition is 13.056 electron volt. And this is the end of our problem, and this is the end of our video, and till next video, Allah Hafiz. Okay.